Alright, welcome to section 2.4. This is the beginning of the next unit of our study, and we're going to use some of the trig knowledge that we have and solve some right triangle type of work. And so these next sections will be all right triangle oriented, and then we will move to non-right triangles, oblique type of triangles that they will have for us. And so there's some statements right across the top about rounding and significant digits. However, they don't seem to hold to that. So I'm going to ignore that. We're going to round for the convenience of the class, answers can be rounded to the tenths place. I want you to take a look at that. But angles must add up to be 180 degrees. Don't stress too much about that. Do natural rounding. It should be matched as you try to match answers in the back of the book as you do the recommended problems. Don't skip those recommended. And so we can totally solve a right triangle. What you remember is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And you also know that the sum of the angles of a triangle is 180 degrees. We're going to use those two facts in order to solve triangles. And so some of the problems will just be like we have here in exercise 1 that's related to number 12 in our text to solve the triangle. Well, no problem. Let's go ahead and solve this triangle. If we're going to solve it, we need to identify what angle B is, and we need to identify little b and little c, those side lengths that are in there. So we need this guy right here, and we need to find out little b and little c, and then we would know everything about that triangle. So let's go find, for lack of a better thing to do first, let's go find that angle. So I'll come in here in blue, and let's go get that angle. What I do know is that in the triangle already is a 90-degree angle and a 31-degree 40-minute angle. So now I know there's 121 degrees 40 minutes of angle already taken up. So what do I know? I know that the sum of the angles of a triangle is 180. So all I have to do is take 180 degrees and subtract away the 121 degrees 40 minutes. Well, that's a little bit of a problem. We're going to have to come in here and replace the 180 degrees by going down a degree and translating out that extra degree to its minutes. If I do the subtraction, I get a nice 58 degrees 20 minutes. That's what angle B is. So going into this triangle, we'll write the answers right over here. Angle B, capital B, is equal to 58 degrees 20 minutes. And we've gotten all the angles of the triangle now. If you're alright, I guess you can't tell me otherwise because it's a video, but I'm going to erase this. You can back up and see that. So we've used this guy, and now we're going to use the sine, cosine, and tangent relationships that are in there. Now, I would recommend using the degree that was given to you. That's what I'll always model. So, for example, I'm going to use angle A. So as I come in here, I know that the sine of 31 degrees 40 minutes is equal to the opposite. Well, the opposite is 35.9 over the hypotenuse, which I don't know, c. And so notice that the numbers I'm using are all given to me in the problem. If you can do that, that's what's highly suggested. Now, you want to make sure that your calculator is in degree mode, not radian mode. So take a moment to put it in degrees. On my calculators, there's a little DRG button that'll allow me to select between them. It's up at the top. So I'm going to take a moment to solve this for C. If I solve it for C, if I move C up, I'll leave the 35.9 over here and bring back over the sine of 31 degrees 40 minutes. So from your algebra point of view, that should not be earth-shattering. You can see that I multiplied both sides by c, gotten rid of there, and divided both sides by sine of 31 degrees 40 minutes. You find that and you'll have it. So I'm going to type in 35.9 in my calculator. Divided by, I'm going to hit the sine button, it's going to have an open parenthesis, and then I'm going to type in the 31 degrees. Now to handle the minutes, we've got to convert those to degrees, so I'm going to add plus 40 divided by 60. So on my calculator, I'm typing in 35.9 divided by sine, and it has an open parentheses, and I type in 31 plus 40 divided by 60. That's going to tell me what fraction of a degree that is. Close the parentheses and hit equals, and we have our answer, 68.3. So little c is 68.3 kilometers. Put those units on there. Awesome. Now, remember my goal. My goal is to use numbers that were already given to me. So I'm going to stick with the 31 degrees 40 minutes, and now I got to go get b. Well, if I'm going to get b, a relationship that has the 35.9 and the b would be tangent. So let me come in here and look at the tangent of 31 degrees 40 minutes. That's going to be opposite 35.9 over adjacent b. So again, what's b going to be equal to? It's going to be equal to the 35.9 divided by the tangent of 31 degrees 40 minutes. And you become really good manipulators of information, and that's what we really want out of this class. So typing in the same way, 35.9 divided by tangent, and in parentheses 31 plus 40 divided by 60. Close that and hit equals, and I'm done. B is equal to 58.2 kilometers. So I know what little b is, I know what little c is, and I know what the angle is. I'm completely done. I've solved that triangle. Expect something like that on the exam. So down here, they're teaching us about angles of elevation and angles of depression. So I'll read this with you. In applications of right triangles, the angle of elevation from point x to y is the acute angle formed by xy and the horizontal ray. So the ray has to be horizontal. So here's your horizontal ray, and here's your xy, and we're going up, so it's an angle of elevation. If you're going down, then it's an angle of depression. Okay. So they'll have some word problems in there. This is a very representative one. It happens to be number 56 in the text. The length of the shadow of a flagpole is 55.20 feet, and the length of the shadow of a flagpole 55.20 feet tall is 27.65 feet. Find the angle of elevation of the sun to the nearest hundredth of a degree. All right, so let's go find that guy. So here is our flagpole, and our flagpole is 55.20 feet tall, and the shadow length is 27.65 feet. And so that is the shadow coming down. This angle right here is theta. This is the angle of elevation, right? Because it's got to be off of the horizontal. So that's the angle that we're looking for. Notice that it will be the exact same as this angle of depression. So it really depends upon what your focus is. But they did say angle of elevation, so this is the angle they want. And because of our two parallel lines being crossed by a transversal and alternate interior angles being equal, it's going to be the same as this angle. So when I initially did the problem before doing this video, I found the angle of depression. I didn't read it exactly right, but no problem. We can totally do that. How should we go about doing that? Well, we want this angle right here. I don't necessarily care about that one. So let's go, oops, have my eraser on still. So let's focus on the angle that we want. So the angle that we want is right down here. It's this one. Let me go ahead and erase these other things that we don't want. We really care about this guy right here. What is this angle? I'll call it capital A. No problem. Do you see a relationship already that you can use? We can definitely use that the tangent of A is equal to the opposite over the hypotenuse. Now remember, we want A. So how are we going to get A? You're going to use your tan inverse function, and you're going to type in 55.20 and divide it by 27.65 and see what happens. So let's go find that tan inverse button. I have to hit a second. It's above my tangent. Opens up with the parenthesis. That's nice. 55.2. Again, make sure you're in degree mode because all the answers are in degrees because that's what elevation angles are measured in. and we're done. A is equal to 63.39. So in the book they put 63.4 degrees. They round to that nearest one. So that's it. It's a matter of understanding what they're asking for and using the triangle that's created in order to find your angle of elevation. And again, it's an angle of elevation because it's going up from that horizontal right there. All right. Let's go ahead and end this video, and we'll come back to the 2.4 word problems in which we're going to try others.